integration is integration by parts. Integration by parts used for some of the integrants that cannot be integrated by substitution or any common method. Okay, so first step, we need to simplify. Then, if the integral cannot be integrated directly, we need to use integration by substitution. If the substitution method cannot be used, we need to choose integration by parts method. For by part method, we let u and v, okay, are differentiable functions of x. By integrating the product rule of differentiation, then integration by parts states that integrate u dv equal to uv minus integrate v du. And to choose u, we can use acronym LOPAC. LO for log function, P for polynomial, E for exponent, and T for trigo. This is the priority to choose u. The second integral, integrate v du, must be simpler than integrate u dv. If your integrate v du is more complicated, meaning that you are choosing the wrong or not suitable u. And in some cases, we need to repeat integration by parts more than once. So now you need to remember this formula. Integrate u dv equal to uv minus integrate v du. This is the formula for integration by parts. So we go to example number 10. Find the following integrals. If you look at the given function, we have x. X is a polynomial and exponent is an exponential function. Usually, we will use by parts method if both functions are from the different family. Okay, so now for integration by parts, we need to choose u. Look at the priority to choose u here. LOPAC. Is there any log function? No. No log function here. For poly function, we have x. And exponent, we have exponent x. And no trigo function. Meaning that your x here, your x will be chosen as your u. So we divide into two parts. We have u and another one is dv. Okay. Back to the formula, we have integrate u dv equal to uv minus integrate v du. For the given integral here, one will be u and the rest will be your dv. Okay, so your u is x and your dv is exponent x dx. For u here, we have u equal to x. So du dx equal to 1. Therefore, du equal to dx. And for v, if we refer the formula, we have u times v. Meaning that from dv here, we need to find what is v. Therefore, we need to integrate both sides. Integrate dv equal to integrate exponent x dx. So, v equal to ex. And we can ignore plus c, the integral constant, because after this, we will integrate v du. Okay, and we will plus c here. Okay, now, if you notice, for the first part here, we need to differentiate. And for the second part, dv, we need to integrate. So, for by parts method, we need to differentiate u and integrate dv. Now, we use the formula, we apply the formula. So, integrate x exponent x dx equal to uv. So, x exponent x minus integrate v du. V is exponent x and du is dx. We state the function all in terms of x. And now, we copy x exponent x uv part and then minus integrate exponent x is exponent x divided by 1. Or exponent x only. And we need to write plus c. Okay, so this is the step 4 by parts technique. Next, we go to example part B. 2x exponent negative 3x plus 1. How to choose u? Okay, we need to check the function first. We don't have log function. We have 2x, the polynomial function, and exponent negative 3x plus 1, the exponential function, and no trigo function. Meaning that we will use 2x as u. Okay, we separate into 2. We need to differentiate u equal to 2x to get du dx. And we need to integrate the rest. The rest is exponent, we need to write dv equal to exponent negative 3x plus 1 dx. So, du dx equal to 2. Or du equal to 2 dx. Okay, we will substitute, replace du here, du, okay, from the formula with du equal to 2 dx. And for the second part dv, we need to integrate. So, v equal to exponent negative 3x plus 1 divided by negative 3. Okay, we got negative 3 from the derivative of the power. Okay, now we will use the formula integrate u dv equal to uv minus integrate v du. For this case, we have integrate 2x exponent negative 3x plus 1 dx equal to u times v. So we have negative 2x exponent negative 3x plus 1 over 3. Okay, and minus integrate v du. Our v is exponent negative 3x plus 1 over negative 3 times du is 2 dx. Then we need to simplify first. We have negative 2 over 3x exponent negative 3x plus 1. Then plus 1 over 3, the constant. We differentiate exponent negative 3x plus 1. Sorry, we have 2 here, so we need to write 2 over 3 as the constant. Integrate exponent negative 3x plus 1 is exponent negative 3x plus 1 over negative 3 and then plus c. And as the final answer, we need to simplify. So we will get negative 2 over 3 x exponent negative 3x plus 1 minus 2 over 9 exponent negative 3x plus 1 plus c. Part C, integrate x cos 3x. X is a polynomial. We have x. And cos 3x is the trigo function. And both are from the different family. For different family, usually we will use by parts. And for Lopet here, this is the priority to choose u. So we divide into 2 parts. We have to differentiate u, and u is x. And we have to integrate dv. dv is cos 3x dx. X is u and cos 3x dx is v. Because we need to compare with the formula u dv. Okay, so integrate u dv is the formula for by parts technique. So now we differentiate u, du dx equal to 1 or du equal to dx. Next, integrate dv. We integrate both sides. So we will get v equal to sine 3x over 3. Okay, as I told you just now, we can ignore plus c, the integral constant first. Back to the formula, we have integrate u dv equal to uv minus integrate v du. For the question, we have integrate x cos 3x dx equal to uv will be x sine 3x over 3 minus integrate v is sine 3x over 3 and du is dx. equal to x sine 3x over 3. We just need to copy. Then minus integrate sine 3x will be negative cos 3x over 3, the original constant, and then times 3. 3 here is from the derivative of the angle plus c. Therefore, the final answer is x sine 3x over 3 plus cos 3x over 9 plus c. Part D. Integrate ln x dx. We compare with integrate u dv. Log function is ln x. And we don't have any other function. But actually, this is equal to ln x times 1 dx. Actually, we have 1 here. And 1 is equal to x power of 0. So, we put 1 under polynomial. So, for this case, we need to differentiate u equal to ln x and integrate dv equal to 1 dx. Ln x is u, therefore 1 dx will be dv. Differentiate u equal to ln x, we will get du dx equal to 1 over x, or du equal to 1 over x dx. For dv, we need to integrate dv to get v. We need to v to substitute into the formula for by parts. Therefore, v equal to x. Now, we copy the formula, integrate u dv equal to uv minus integrate v du. For this question, we have integrate ln x dx equal to uv. X ln x minus integrate v is x, du is 1 over x dx. For v du, x can be simplified with x here. So we have x ln x minus integrate 1 dx. Therefore, the answer is x ln x minus x plus c. Integration by partial fractions. For partial fractions, you need to make sure that the function is a proper fraction. So, for this method, you need to recall your partial fractions that have been learned in your first semester under chapter polynomial. If your denominator is a linear function, we need to use constant as the numerator. So, this is under linear factor. And for repeated linear factor, repeated linear factor, we need to increase the power one by one. First, we have a over x minus 1 plus b over x minus 1 squared. We increase the power one by one. Next, for quadratic factor, we have to write bx plus c as the numerator. If the denominator, the factor is quadratic, this is a quadratic, the numerator must be a linear. And for this case, we have a over x. A is a constant, x is a linear factor. Next, 2 over x times 4 minus x squared. At first, for this factor, this is a quadratic factor, but we need to factorize. We have 2 over x times 2 minus x, 2 plus x. You need to use linear factor, except for a quadratic factor that cannot be factorized. For the quadratic that cannot be factorized, we need to use bx plus c or ax plus b as the numerator. Okay, class? So, we go to example number 11. Integrate 5 over x times 1 minus x. If you notice here, we have factor form as the denominator. Usually, we will use partial fraction. What is the type of factors in your denominator? Yes, this is a linear factor. So, we take out the function 5 over x times 1 minus x equal to, we ignore the integral first. Okay, we go to partial fraction. So, we write a over x because x is a linear plus b over 1 minus x. Next, we equate the denominator. So, we have 5 equal to a times 1 minus x plus b times x. And after this, you can choose either you want to use a substitution method or elimination method. Sorry, substitution method, or maybe you can compare. Okay? For now, I want to use substitution method. When x equal to 1, we substitute into the equation. We have 5 equal to b times 1. Because 1 minus 1 is 0. A, automatically a times 0 will be 0. Therefore, b equal to 5. Okay, next, when x equal to 0, 5 equal to a times 1 minus 0 is 1 plus b times 0 is 0. So, a times 1 plus 0. Therefore, a equal to 5. So, 5 over x 1 minus x equal to, we replace 5, a equal to 5 and b equal to 5 into the partial fraction. So, we have 5 over x plus 5 over 1 minus x. So, this is the answer for the partial fraction. Now, we go to the integral. Integrate 5 over x times 1 minus x dx is equal to integrate 5 over x plus 5 over 1 minus x dx equal to 5 ln x and then plus 5 ln 1 minus x divided by negative 1 plus c, or equal to 5 ln x minus 5 ln 1 minus x plus c. Part B, we have 2x minus 1 over x squared minus 2x minus 3 can be factorized. It can be factorized as 2x minus 1 over x minus 3 x plus 1. Now, we will write the fraction in the general form of partial fraction. We have 2x minus 1 over x minus 3 x plus 1 equal to a over x minus 3 plus b over x plus 1. Then, we equate the denominator and we substitute a suitable value of x. For this case, we substitute x equal to negative 1. So, 2 times negative 1 minus 1 equal to a times negative 1 plus 1 is 0. And plus b times negative 1 minus 3. Therefore, you will get b equal to 3 over 4. Next, when x equal to 3, 2 times 3 minus 1 equal to a times 3 plus 1 plus b times 0. Therefore, a equal to 5 over 4. The partial fraction of 2x minus 1 over x minus 3 x plus 1 equal to 5 over 4 times x minus 3 plus 3 over 4 times x plus 1. Therefore, the integration of 2x minus 1 over x squared minus 2x minus 3 dx equal to integrate 5 over 4 times x minus 3 plus 3 over 4 times x plus 1 dx equal to 5 over 4 ln x minus 3 plus 3 over 4 ln x plus 1 plus c. Part C, 2x plus 4 over x cubed minus 2x squared can be written as 2x plus 4 over, we factorize x squared, bracket, we have x minus 2. Next, we proceed to partial fraction. So 2x plus 4 over x squared times x minus 2 equal to x squared is a repeated linear factor. A over x plus b over x squared plus c over x minus 2. 2x plus 4 equal to a times x minus 2 plus b times x minus 2 plus c x squared. When x equal to 0, we have 2 times 0 plus 4 equal to a times 0 plus b times 0 minus 2 plus c times 0. Therefore, b equal to negative 2. When x equal to 2, 2 times 2 plus 4 equal to a times 0 plus b times 0 plus c times 2 squared. Therefore, c equal to 2. And the last one, you can substitute any value of x. Let's say I want to substitute x equal to 1. So we will get 2 times 1 plus 4 equal to a times 1 times 1 minus 2 plus b times 1 minus 2 plus c times 1 squared. Next, you need to substitute your value of b and c inside. Replace your b with negative 2 and your c with 2. Therefore, you will get a equal to negative 2. And the partial fraction, 2x plus 4 over x squared x minus 2 equal to a over x, negative 2 over x, plus b over x squared, minus 2 over x squared, plus c over x minus 2, becomes plus 2 over x minus 2. Therefore, the integration of 2x plus 4 over x cubed minus 2x squared dx equal to integrate negative 2 over x minus 2 over x squared plus 2 over x minus 2 dx. Then we have negative 2 ln x. Next, plus 2 over x plus 2 ln x minus 2 plus d. Now, we are using d because we have used c from the previous part. For part D, we have 5x squared plus 4x plus 12 over x plus 2x squared plus 4. X squared plus 4 is a quadratic factor that cannot be factorized anymore. So we will proceed to use the quadratic factor. So we have a over x plus 2 plus bx plus c over x squared plus 4. By equating the denominator, we have 5x squared plus 4x plus 12 equal to a times x squared plus 4 plus x plus 2 times bx plus c. When x equal to negative 2, we substitute. We have 24 equal to a times 8. 2 squared is 4. Negative 2 squared is 4. Plus 4 is 8. And the next term equal to 0. Therefore, a equal to 3. When x equal to 0, okay, so 12 equal to a times 4 plus c times 2. By using a equal to 3, we will get 3 times 4 plus 2c. Therefore, c equal to 0. And the last one, we can substitute any value of x for the third constant. Okay? So we have 21 equal to 3 times 5 plus b times 3. Therefore, b equal to 2. Then the partial fraction 5x squared plus 4x plus 12 over x plus 2 x squared plus 4 equal to 3 over x plus 2 plus 2x over x squared plus 4. Because c equal to 0. Next, integrate 5x squared plus 4x plus 12 over x plus 2 x squared plus 4 dx equal to integrate 3 over x plus 2 plus 2x over x squared plus 4 dx equal to 3 ln x plus 2. And for the second term here, we can apply the rule of integrate f prime x over fx dx equal to ln fx plus c. So the answer is 3 ln x plus 2 plus ln x squared plus 4 plus d. Because we have c already. So I'm using d. But for those who cannot remember this rule, you can use substitution method. Question part E. 1 over r cubed minus r can be written as 1 over r. We factorize r. So we have r squared minus 1. And it still can be factorized as r times r plus 1, r minus 1. Tadi saya dah cakap dah, walaupun dia tu kuadratik, tapi kita kena reduce kepada linear. Kalau tak dapat factorize, barulah kita terpaksa guna kuadratik. Selagi boleh guna linear, gunalah linear factor. Okay, so now we proceed to partial fraction. We have 1 over r, r plus 1, r minus 1 equal to a over r plus b over r plus 1 plus c over r minus 1. 1 equal to, okay, for now, we need to equate the denominator. So 1 equal to a times r plus 1 times r minus 1 plus b times r minus 1 plus c times r plus 1. Next, we substitute the suitable value of r. Now we are using r as variable. When r equal to 0, 1 equal to a times 0 plus 1 is 1, 0 minus 1 is negative 1, and the rest becomes 0. Therefore, we will get a equal to negative 1. Next, when r equal to negative 1, 1 equal to, okay, a part becomes 0. So we have 0 plus b times negative 1 times negative 2, and the third part, c part, is also 0. Therefore, your b is half. And the last one, we substitute r equal to 1. We have 1 equal to, part a becomes 0, plus part b is also 0, plus c times 1 times 2. Therefore, c equal to half. So, 1 over r, r plus 1, r minus 1 equal to, a is negative 1. Negative 1 over r plus 1 over 2 times r plus 1 plus 1 over 2 times r minus 1. So, integration of 1 over r cubed minus r dr equal to integration of negative 1 over r plus 1 over 2 times r plus 1 plus 1 over 2 times r minus 1 dr. And we will get negative ln r plus half ln r plus 1 plus half ln r minus 1 plus d.